This research paper examines the limitations of artificial agents in replicating human-like moral reasoning, arguing that explicit ethical machines cannot be considered moral agents. The author leverages Alan Turing's theory of computation to demonstrate that moral reasoning is computationally intractable due to the halting problem. This problem states that it is impossible to predict with certainty whether a computational process will halt, introducing critical limitations in artificial agents' decision-making abilities. The paper formalizes moral problems into algorithmic moral questions and explores moral psychology's dual process model. While Turing machines theoretically allow artificial agents to engage in recursive moral reasoning, the halting problem limits their ability to make decisions in all instances, undermining their moral agency. A thought experiment involving a military drone illustrates this issue, showcasing the agent's potential failure to decide between actions due to the halting problem. The author defines artificial agents and discusses the rationale for widening the notion of moral agency to include machines. The properties and limitations of artificial agents are examined through the lens of Turing machines, highlighting the impossibility of guaranteeing that they will make moral decisions at all times and in all circumstances. This limitation is not due to the specific normative ethical framework they must adhere to, but rather the computational intractability of moral reasoning. The paper critiques the methodologies suggested by various academics for representing moral rules and principles within explicit ethical machines. Moore's categorization of explicit ethical machines is also examined, revealing that these machines are unable to replicate human-like moral reasoning. The author concludes that it is not possible to guarantee with absolute certainty that explicit artificial agents will always arrive at a decision when faced with moral questions, a condition necessary for an agent to be considered a moral agent. Here is a combined summary of pages 3 and 4 of the research paper. Expanding the scope of moral agency to artificial agents is a crucial aspect of artificial moral agency. Floridi and Sanders, 2004, argue that artificial agents should be recognized as capable of moral agency, as the focus on moral patience has led to an imbalance in moral responsibilities. To overcome this, academics have suggested widening the concept of moral agents to include natural and legal persons, such as governments and corporations. However, this approach is criticized for being overly anthropocentric, and artificial agents should be included as entities capable of moral agency. Artificial agents are defined as advanced computational systems that sense and act autonomously to achieve specific objectives, interact with various environments, exhibit learning capabilities, and plan and execute new strategies. These attributes are essential for exploring their moral faculties. Turing machines provide a fundamental mathematical framework for studying artificial agents making moral judgments. They offer three key benefits: modeling a wide range of computational processes, including moral problems, self-referential capabilities for recursive reasoning, and understanding the limitations of digital computers and artificial agents. Turing machines are abstract computational models that manipulate symbols according to a set of rules, simulating the logic of an algorithm. The Universal Turing Machine, UTM, can emulate and reproduce the behavior of any Turing machine, making it immensely versatile. Scholars have postulated that UTMs can reproduce any mechanical procedure, including moral reasoning, as long as they can be encoded algorithmically. For the purpose of this analysis, it is assumed that moral reasoning can be analyzed by UTMs. This foundational framework sets the stage for examining the nature of artificial agents and their capabilities in making moral judgments, highlighting the significance of exploring their moral faculties and the potential of Turing machines in modeling and understanding artificial moral agency. Turing machines, as abstract computational devices, possess the ability to simulate themselves, enabling self-reference and recursive reasoning. This capacity allows them to analyze, understand, and optimize computations by referencing their own programs. However, their self-referential nature also leads to limitations, such as the potential for creating self-contradictory programs. The halting problem, a fundamental limitation of Turing machines, reveals that they cannot predict in advance whether they are able to give an answer to specific problems. This inability to predict outcomes has profound implications for computational ethics, particularly in the development of artificial moral agents. The research on the frontiers of machine ethics identifies the limits of artificial agents in ethical reasoning. It approaches this topic in 3 steps: formulating moral problems in algorithmic terms, analyzing moral psychology's ethical reasoning, and examining how artificial agents answer these questions. The analysis concludes that creating certain types of artificial moral agents is impossible due to the halting problem. The concept of algorithmic moral questions is introduced, which includes yes or no type questions and open-ended what type questions. The focus is on yes or no type questions for simplicity, with the understanding that the conclusions are applicable to what type questions as well. The algorithmic moral question is defined as, given an action X, determine whether or not X has moral property P. This formulation provides a universal representation of ethical problems and enables the analysis of how artificial agents can address moral problems using human-like ethical reasoning. The human ethical decision-making process, studied in moral psychology, is also applied to artificial agents. This includes the social intuitionist model and the dual process model of moral decision-making. The dual process model is a normative ethical framework suitable for artificial agents due to its anchoring in concrete ethical frameworks, empirical validation, and focus on rationalization. It influences moral judgments to ensure consistency with prior moral commitments. The model defines moral reasoning as conscious mental activity evaluating a moral judgment's consistency with moral principles and prior judgments. This leads to the formulation of constrained algorithmic moral questions, which ask whether an action has a specific moral property while being consistent with all prior moral commitments. Artificial agents can comply with these questions through self-referential capabilities, examining the impact of future actions on prior commitments and determining contextual coherence. This self-referential reasoning allows them to engage in moral judgments in accordance with the dual process model, ensuring coherence between new and past actions. The discussion on moral reasoning in algorithmic systems highlights the constraints imposed by the dual process model on new actions to maintain moral coherence. This concept is linked to the self-referential nature of Turing machines, which enables artificial agents to make moral judgments. However, it is argued that artificial agents are incapable of making genuine moral judgments due to the halting problem, making human-like moral reasoning computationally intractable. The field of machine ethics differentiates between implicit and explicit ethical machines, with implicit machines acting ethically through hard-coded features and explicit machines equipped with moral principles. Research has focused on explicit moral agents, employing top-down and bottom-up approaches. Top-down approaches encode predefined ethical duties, while bottom-up methods deduce ethical norms from real-world data. Both approaches have limitations, with top-down approaches being too broad and bottom-up methods lacking reflection on abstract matters. This complex interplay between moral reasoning, computational constraints, and ethical frameworks underscores the challenges in creating artificial agents that can engage in human-like moral decision-making. The research discusses the limitations of top-down and bottom-up approaches in developing artificial moral agents. It argues that a hybrid method combining strengths from both approaches is the best solution. The study questions the effectiveness of explicit ethical machines, which use a bottom-up approach, in making human-like moral decisions. It highlights the limitations introduced by the halting problem, making it impossible to determine with certainty how these machines will function in unseen scenarios. The concept of a moral checking machine is introduced to illustrate the impossibility of constructing a Turing machine that can predict with absolute certainty an artificial agent's decision-making process in novel scenarios. A thought experiment involving a military drone controlled by an explicit ethical machine is presented to further demonstrate these limitations. The research emphasizes the need for a hybrid approach and the importance of considering the halting problem in the development of artificial moral agents. The research discusses the moral dilemma faced by an artificial agent, tasked with destroying enemy aircrafts while minimizing collateral damage and respecting international law. The agent's mission is to strike a military base, but it encounters civilians being used as human shields. The agent must reassess its action, considering 2 options: continue with the strike, risking civilian casualties, or abort the mission to spare lives. The decision-making process for the artificial agent differs from that of a human operator, as it will continue searching for new actions indefinitely without reaching a conclusion. To address this, the concept of a moral checking machine is proposed, ensuring the agent's actions are morally justifiable. The research highlights the complexities of autonomous decision-making in dynamic environments, emphasizing the need for a system that can guarantee moral certainty in the face of uncertainty. In the context of machine ethics, the capability of artificial agents to make ethical decisions is inherently limited due to the halting problem, as posited by Turing's theory. This limitation arises from the uncertainty of whether a decision will be made or if the system will run indefinitely. The moral checking machine thought experiment illustrates this concept, where a military drone controlled by an explicit artificial agent may strike a target not due to a deliberate decision but rather because it is unable to determine a corrective action. The halting problem indicates that even the most advanced artificial agents cannot guarantee with certainty that they will arrive at a decision, implying that knowledge of whether a decision is computable remains uncertain until the moment it is made. This limitation is not a result of the agent's nature but rather an inherent limitation in its internal process. The challenge of creating explicit artificial moral agents lies in the impossibility of emulating the human-like moral decision-making process. The unpredictability of explicit ethical machines' behavior in making decisions, due to their inferred ethical knowledge base, highlights the limitation in their moral decision-making capabilities. Consequently, it is impossible to create explicit ethical agents capable of moral reasoning whose knowledge base is constructed by a bottom-up approach. This limitation applies to any machine learning model, including neural networks, generative models, and large visual models, as they are constrained by the physical devices upon which they are implemented and hence by the halting problem. Implicit ethical machines and top-down explicit ethical machines, which operate within a limited range of action and adhere to rule-based moral principles, respectively, may exhibit reduced unpredictability in their behavior. However, the limitations of bottom-up explicit ethical machines remain an intractable problem. The distinction between these approaches warrants further investigation, which is beyond the scope of this essay. Ultimately, the creation of explicit artificial moral agents is hindered by the fundamental limitations of computing machines, as revealed by Turing's theory. The summary begins by highlighting the importance of ethics in artificial intelligence, referencing key works such as Artificial Morality, by Alan et al., and Learning in Multi-Agent Systems, by Alonso et al. It then delves into the concept of computational ethics, citing Awad et al.'s work on the subject. The discussion turns to the legal aspects, mentioning Chopra and White's legal theory for autonomous artificial agents. The section concludes with a mention of the significance of moral reasoning, as explored in Paxton and Green's research. The summary seamlessly transitions to the computational complexity of ethics, referencing Stensike's work, before ending with a nod to the foundational work of Turing and the ongoing discussions around moral machines, as presented in Wallach and Valler's research.